What happens when you throw an F1 inspired V10 engine and SMG transmission into a rear-wheel drive German large sedan? You get this. Introducing the BMW E60 M5. Produced in 2005, the E60 M5 is the world's first mass-produced sedan to use a V10, which you often see in supercars like the Gallardo, the R8, and eventually greats like the Lexus LFA. This was a true statement in performance, as it became the world's fastest sedan at a time, with a top speed of 205 miles per hour, which is almost 330 kilometers an hour. Some modern supercars aren't even that quick, but its straight line performance doesn't quite paint the full picture. Here at Intuitive, we appreciate the intensive engineering thought undertaken to make the outlandish idea of a rear-wheel drive V10 sedan possible. We'll conduct an Automotive X-Ray on the E60 M5, technically analysing the engine, transmission, dynamics, suspension, and of course the chassis and underbody. With all that out of the way, let's begin. Let's start with what powers this super saloon. It's the only V10 production engine ever built by BMW, and it's a 5-litre V10 S85 B50, making exactly 500 horsepower at 7,750 RPM and 520 Nm of torque at 6,100 RPM. This engine wasn't just used in the E60 M5, it was also used in the E63 M3, which is basically a shorter and lighter version of the E60 M5. Inspired by the BMW Sauber F1 program, the S85, like the S65, had nothing in common with previous BMW M engines of the past, which were usually inline-sixes like the S54 from the E46 M3. Let's now examine some of what makes this S85 so unique. The S85 engine uses a cast aluminum block in a two-piece alusil crankcase with a reinforcing bedplate that is machined with the crankcase during assembly. This bedplate assembly contains cast iron bearing bridges, which absorb extra forces from the pistons and connecting rods, so that's why it's so powerful. The S85 also uses cross-flow cooling, though each cylinder had its own radiator feed, and the coolant thermostat was located on the return flow line. The radiator had an upper and lower tank for the first and second cylinder banks. The S85 also boasts a forged steel crankshaft that was nitro-carburized for increased surface hardness. This crankshaft also had 5 crank pins, each offset 72 degrees apart, and these produce an uneven firing interval of 90 or 54 degrees. The S85 also featured CNC machine ports and combustion chambers, and the valves were actuated through non-rotating inverted bucket cam followers. The S85 has shining, stainless steel, hydroformed exhaust manifolds. The exhaust tubes had a 5-into-1 design with one near-engine catalyst per cylinder bank. Before we move on to the rest of the engine internals, let's appreciate the glorious V10 induction note that makes the E60 M5 such a euphoric experience by simulating this car in the Scottish capital of Edinburgh. Well, I hope you enjoyed that. Connected to these exhaust manifolds is a one-piece aluminum cylinder head and a cast aluminum cylinder head cover. The hollow chill cast camshafts have BMW's high-pressure double variable valve timing system, which is called VANOS, and uses a high-pressure pump that is driven directly from the crankshaft via a gear-to-gear connection to provide pressure up to 115 bar. But this dual VANOS system isn't without its faults, and when you combine high oil temps, despite an oil cooler being installed from the factory, you're very likely to experience premature VANOS solenoid failure, which can result in rough idle, loss of power, or check engine lights. Scouring the bid and post forums reveals the main culprit of this issue to be extremely tight clearances in the S85, an unfortunately unreliable theme which we will explore more throughout this section, with the clearance in the Vanos solenoid between the spool and cartridge bore being only 0.0001 inches. With such a small clearance, the soft bearing swath gets trapped in the middle, causing too much drag on the spool. This causes the DME, which is BMW lingo for ECU, to hunt in finding the target value of the spool instead of performing the relevant Vanos operations as required. Each intake camshaft had a single roller timing chain, while the exhaust camshafts were driven by a gear-to-gear connection between the intake camshaft sprocket and the exhaust camshaft sprocket. The intake camshaft had 60 degrees of adjustment, while the exhaust camshaft had 37 degrees of adjustment. Although the S85 engine did not have dry sump lubrication, two electrically semi-dry oil scavenge pumps that feed oil from the smaller sump to the main sump were activated when a G-force of 0.8 was reached to ensure oil starvation doesn't occur during track driving. I reckon Subaru should learn a thing or two about this. And we're not done yet. There are 3 different engine modes that you can choose from: P400, P500 and P500S. P400, the default starter mode, only uses 394 horsepower, whilst with P500 you now have the full 500 horsepower on tap. The P500S mode meanwhile adds a more sensitive throttle response. Speaking of throttle response, air supply to the engine was controlled by a whopping 10 individual throttle bodies, 1 per cylinder, which were electronically actuated by 2 throttle motors, 1 per cylinder bank. Unfortunately, these throttle body actuators are susceptible to failure, and this can cause the car to enter limp home mode, with these failures having been reported from 50,000 kilometers. In classic BMW fashion, the gears within the actuators are made from plastic and wear over time, causing uneven mesh and increased friction. To offset this friction, the control board applies extra current to the motor, but the circuit control board doesn't have enough overcurrent protection, so the driver MOSFETs fail due to source to drain shoot through, which may also cause the gate lead to fail. This ends up damaging the gate driver circuitry and renders the circuit board inoperable. That sure does sound like a nasty domino effect. Inside the combustion chamber, the S85 used aluminum alloy cast pistons, operating at a compression ratio of 12.0 to 1, whilst revving all the way to 8250 RPM, with an uneven cylinder firing order of 1, 6, 5, 10, 2, 7, 3, 8, 4, 9. The S85 engine used ionic current technology to detect engine knock, misfiring, and combustion misses. The ionic current satellite received signals from the 5 spark plugs of each cylinder bank. Depending on engine load, the satellite amplified these signals and transmitted them to the engine management system for analysis. Now, onto that small engine clearance theme we talked about earlier. The connecting rod bearing clearance to journal ratio for S85 engines produced from 2007 to October 2008 with the 088/089 bearings is less than what is generally recommended by engine builders. This lack of clearance causes poor oil lubrication between the crank journal and the connecting rod bearings, resulting in those rod bearings going out. So, for the 702/703 bearings that were subsequently introduced, bearing eccentricity was increased for greater clearance. And with that, let's move on to the tasty, if not temperamental, part of this car, the transmission. Just like the engine we just looked at, the E60 M5's auto is also F1 developed as well. It's the first 7-speed sequential manual gearbox to ever be put into a production car, and it lets the driver shift without a clutch pedal in as few as 80 milliseconds. This single clutch SMG can be controlled through a drive logic function, where drivers can choose from 11 gear change options, 6 manual, 5 automatic. The SMG also includes a launch control, a hill holder, wheel slip detection to put the power down, shift lock avoidance by briefly disengaging the clutch during downshifts, and an automatic shift mode, which can feel jerky at low speeds compared to, say, a torque converter, as the SMG has been known to cause the clutch to wear quicker than normal gearboxes. Well, what's the trick behind the SMG? Why is there no clutch pedal in the manual car? The SMG actually uses a hydraulic pump to operate the clutch and shift gears, but there's a caveat to this. Over time, this pump can fail, leading to issues where you might not even be able to shift or the car being stuck in a certain gear. So what if you want to bypass this headache, but at the cost of shifting your own gears? Look to get a 6-speed manual trim of the E60 M5. The manual gearbox for this car is pretty much ripped out of an E60 545i. However, it's only in North America, and it's kind of a unicorn in the used market, with only 1,366 of these gems being produced in manual. Also, if speed's your thing, the manual is quite a bit slower than the SMG version, as the dynamic stability control couldn't be disengaged, unlike the SMG version. However, this was later made possible. The SMG in the E60 M5 also came with a dedicated transmission cooler for the odd track day or two. Now, moving on to gear ratios. If we look at this table which compares the SMG's gear ratios to the manuals, the gear ratios are spaced together much closer in the SMG than they are in the manual, allowing the engine to be kept consistently in the power band as well as to give a consistent acceleration feel. The manual, on the other hand, to compensate for no 7th gear, uses wide ratios, which are very noticeable between 2nd and 4th gear. Let's now move on to another aspect that makes the E60 M5 so special, the dynamics. What's the most common way to make a car turn? By steering it, of course. And with that, let's kick off discussing the steering in the E60 M5. It uses a hydraulic power steering setup, and the steering ratio depends on the amount of lock applied and what drive mode you're in. If you took the mean of all these variable steering ratios, it will be 12.4 to 1, which is really direct for a large sedan of this size. This steering rack is also an M Servotronic setup, meaning the steering gets heavier as your speeds increase, so this gives you heaps of steering feedback when those tires load up with speed. Whilst its predecessor in the E39 M5 introduced this M Servotronic system, it uses a recirculating ball design for the steering system like the E28 and E34 M5, and reviewers have noted an improved on-center feel in the E60 steering rack as a result of changing to a rack and pinion design. To ensure the E60 M5 comes to a stop quickly, BMW have installed big brakes from the factory by using 4-wheel vented and cross-drilled brake discs, which are 374mm by 36mm front discs and 370mm by 24mm rear discs with 2-piece rotors. The front calipers had a dual piston design, and these brakes have been advertised to bring the M5 to a complete stop from 60 miles an hour in just 118 feet, which is just under 36 meters. The braking system in the E60 M5 also had 3 distinct features: brake standby, which prepares for hard braking by pressurizing the pad against the rotor when the driver abruptly reduced throttle input; brake drying, which helps keep the brake pads dry by pressing the brake pad against the rotor when the rain sensor detected moisture; and start off assistant, which applies the brakes for 1 second after the driver takes their foot off the brake pedal to accelerate up a hill. To help put down a staggering 500 horsepower when launching hard, a staggered setup of 255/40 ZR19 at the front and 285/35 ZR19 at the rear has been used, with M radial spoke-like cast alloy wheels that are 19x8.5 at the front and 19x9.5 at the rear. But do you know what makes this E60 M5 hug the corners? A mechanical clutch-based LSD known as a variable M differential lock, which consists of a shear pump and multi-disc clutch. How it works is that when the LSD detects that the rear wheels are slipping, the shear pump will be driven, which would increase the pressure in the viscous silicone fluid that causes the clutch to engage and then send torque to the rear wheel with better traction. The greater the wheel slip, which is the difference in wheel speed between the 2 rear wheels, the faster the clutch will engage. And with that, let's move on to what makes the car roll, pitch and yaw when moving: the suspension. The E60 M5 uses the aluminum gas pressurized double pivot strut type front suspension and a 4-link integral rear suspension. For the first time ever, the E60 M5 came with adaptive suspension from the factory via BMW's electronic damper control, which can be configured to either comfort, normal or sport. These dampers continually adjust both rebound and compression forces in real time, responding to road conditions, driving style, and vehicle inputs. While not manually adjustable in 3 separate ways through rebound and high and low speed compression like race dampers, this setup increases ride comfort over rough surfaces and improves handling dynamics by reducing body roll and pitch under hard driving. But in classic M fashion, extensive changes have been undertaken from the E60 5 series, and these are modified front and rear subframes, revised suspension geometry, stiffer bushings, hollow half shafts, unique rear suspension links with different spring rates, with the E60 M5 now sporting 6K front and 5K rear spring rates, and finally 26.5mm front and 18mm rear anti-roll bars. With that, let's move on to the final piece of the puzzle, the chassis and underbody. How can a sedan travel over 200 miles an hour and not feel unstable and nervous? Well, BMW have made extensive, although subtle, changes to the exterior of the E60 5 series for the M5 through adding a unique front fascia with large air intakes rather than fog lights, wider front guards with gills, unique rocker panels, M-designed door mirrors which have been claimed by BMW to reduce front axle lift at high speeds, a more aggressive rear bumper with a central diffuser, and a lip spoiler. These changes have combined to yield a drag coefficient of 0.31 for the E60 M5, which for 2005 is jaw-dropping considering that the Tesla Model S has a drag coefficient of 0.24, with the exterior design of EVs being almost entirely focused on improving range through reducing drag. As alluded to in the earlier sections, the E60 M5 uses an all-aluminum front end, rear end, and suspension, and some of these material choices have meant that the E60 M5 has a 50-50 front-rear weight distribution from factory. That's me out of territory. And another fun fact, with the E60 M5 tipping the scales at 1,755 kilos or 3,861 pounds, the E60 M5 is not even 1 pound heavier than its predecessor, the E39 M5. So, real world performance time. To really gauge the high speed cornering capabilities of the E60 M5, what better environment to test it in than the Nürburgring? Turns out, the E60 M5 is 7 seconds faster than the E39 M5 on the Nürburgring, and the exact same time as a Dodge Viper SRT10 Roadster. It's also just under 2 seconds slower than the Lamborghini Gallardo Spider. For a large sedan that weighs almost 1.8 tons, that's mighty impressive. Let's head into the concluding remarks. Overall, what are my thoughts on the BMW E60 M5? If you take away its temperamental engine and transmission issues, it's honestly my favourite sedan of all time, just for the sheer insanity of having a V10 that revs to the heavens. And as these cars cost an unimaginable amount of money to repair and maintain if or when catastrophic failure does unfortunately strike, these are available for quite cheap, around the same price as a Lexus ISF, a car that we've conducted an X-Ray on. If you've got any other cars you want us to conduct an Automotive X-Ray on, let us know in the comments. Thank you so much for the support already with the previous 2 X-Ray videos. Let's keep this up. Much love to you all, and I'll see you in a bit.